Hello and welcome back to Saxon Math. This is lesson 110, Symmetry. It's a new concept. A figure has a line of symmetry if it can be divided in halves so that the halves are mirror images of each other. We can observe symmetry in nature. For example, butterflies, leaves, and most types of fish are symmetrical. In many respects, our bodies are also symmetrical. Manufactured items such as lamps, chairs, and kitchen sinks are sometimes designed with symmetry. Two-dimensional figures can also be symmetrical. A two-dimensional figure is symmetrical if a line can divide the figure into two mirror images. Line R divides the triangle below into two mirror images. Thus, the triangle is symmetrical and line R is called a line of symmetry. So, for example, this rectangle has how many lines of symmetry? So keep in mind it's two ways to divide the rectangle into mirror images. There is this way, which you can see it splits it right down the middle vertically, and this way, which splits it down the middle horizontally. It creates two mirror images. This point is exactly the same distance as this point is from that line of symmetry. So this distance right here is the same as this distance. Same goes for this position right here. This would be the same distance as this from the line of symmetry. So this point and this point. Also, on the other side, this point is the same distance, so it makes a mirror image. The rectangle has two lines of symmetry. How can we be sure that there are no more lines of symmetry? Well, in the rectangle, you could split it. If you wanted to try this line, for example, this is a common line that people might look at in some shapes. If you were to go that direction, if this dot is perpendicular, so you check the perpendicular, it has to be perpendicular. So it has to be perpendicular, and if there's another point over here on this side, then it would be a line of symmetry. And you can see in a rectangle that does not work. It does, however, work on a square. Which of these two triangles does not appear to be symmetrical? So in triangle A, you can see that all the sides seem to be equal. Triangle B is a right triangle and it doesn't seem to have the same length of sides except for these two, so it'd be an isosceles triangle. This would be a scalene triangle that has all different sides. So if I was to guess, I would choose A. If you check each triangle to see whether we can find a line of symmetry, choice A, all three sides of the triangle are the same length. So we can find three lines of symmetry in triangle A. In choice B, there's only two choices, or one choice, because there's only two lines that are equal. So it'd be this line right here. You can see this point is the same distance from this point, and it creates a nice 90-degree angle there with that line drawn between the two. Here you would have this line of symmetry. There's a line of symmetry here, and there's a line of symmetry here. On this one, there is no line of symmetry. On C, triangle C, there is no line of symmetry. It is not symmetrical at all. A figure has rotational symmetry if the image of the figure reappears in the same position as it is turned less than a full turn. Remember, a full turn would be 360 degrees. So anything less than a full turn is less than 360, like 90 degrees, 180, or 270 degrees, or anything even if it was 359 degrees, if it reappears magically before 360, then it's still considered rotational symmetry. So for example, this original position of this square, if you turned it 45 degrees, you could see that it's not in its original position yet. But if we turned it one more 45 degrees and we want to complete 90 degrees, which is just one turn to the right, it is its original position. So this is this, they're equal to each other, and it happened in a 90-degree turn. If we went further, it also happened again at 180, and if we went further, it would also happen again at 270 degrees. If we did 360, we'd be back to the original square, and that wouldn't be considered rotational symmetry if it took us that many turns. But here you can see it happen once, twice, it happens 3 times before. So it has to be less than 360 degrees, and in this case it is. So it's rotational symmetry. Which of these figures have rotational symmetry? Choose all the correct answers. So if you were to rotate this, for example, let's just grab it. You can see here, I've got it in its original position. If I turn it 45 degrees, it doesn't show its original position. If I go 90 degrees, it is not its original position. If I go a little bit further than that, it's not in its original position. If I went to here, I can see it actually works. So I didn't go all the way around. So here was my original position. So watch, here's 90, here's 180. So at 180, I'm back to my original shape, not here, and 270. So it looks like it happens to work at 180, and it works again twice there. Well, that's 360. So it goes 180 and 360. That would be considered. So there's 180 there, and there's 360. So we're back to the original position, but it happened before 360. So because of that, we've got rotational symmetry on that one. Let's try this shape here. See if I can just grab the shape. I don't want the whole square, I just want this shape. So if I was going to rotate this, let's see, there's 90. If I go 180, look at that, 180. So if I'm going from this side and I bring it over here, that's 180 degrees. And that's the original position again. So that means that has rotational symmetry. Let me see if I can grab this again. Let's see. No, there we go. So if I'm going to rotate this one at any point, no, that's not going to work. No, no, no. Nothing, nothing, nothing until I go all the way back to the original. So I had to go 360 degrees, so that one does not work. So A is not something that has rotational symmetry, or C does not have rotational symmetry. And if I look at the last one, this triangle, right triangle, rotating it. If I rotate it, it looks like I have to go all the way back. So I have to move all the way around 360 degrees before it finally gets back to its original position. So that means that one does not have rotational symmetry either. It has to be able to happen before you do 360 degrees. So choices A and B do have rotational symmetry, and choices C and D only appear or reappear after a full 360. So that means they do not have rotational symmetry. All right, so for letter A, viewing the four squared pictures below, which blue line does not represent a line of symmetry? So would it be A, B, C, or D? Which one is not representing a line of symmetry? It should be, in this case, A. You should have chosen A as your best option for the picture. Letter B, all but one of these letters can be drawn to have a line of symmetry. Which of these letters does not have a line of symmetry? So if I was going to draw with the line tool, and I'm looking at A, I see that I can draw a line right down the middle here, and I would have a mirror image on both sides. B, I can see I have another mirror image there, it looks like. C, it looks like I could have a mirror image if I move that right between that, so that would work. D seems to have a line of symmetry if I move that and have that down a little bit lower. See if I can move that down a little bit lower for visuals. So there, that's a line of symmetry there. And if I went to E, clearly that's a line of symmetry right there. Letter F, I don't see any place where I could draw a line. You see this doesn't have the same on the top and bottom there, so that won't work. I can't draw it right here because there's no mirror image of it on this side. Going this direction, I don't see anything working that way. This almost works, but no, it doesn't because there's no mirror image on the other side. So letter F is the best choice for the answer. That one does not have a line of symmetry. And letter C, which two of these letters have rotational symmetry? So the hint says rotating your book might help find you the answer. We can also do this real quick. Rotational symmetry, remember it was rotating it within, if it comes back to its original position before 360 degrees, then it would be it. This is not, so this would be approximately 180. So that'd be 180, 270, 360. So this one doesn't look like that. That does not have rotational symmetry. So that one does not. I'll leave it there. Let's try letter M. Let's see, there's 180. Nothing in between, nothing, 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 nothing. Nope, nothing there. So we'll leave M there. Let's try N. So if I go, oh, that looks like I only went 180 degrees. So if I went, flip it on its side, but then I'm back here. So at 180 degrees, yeah, that works. 180, that worked. O, I think that one's pretty obvious. You can't even really tell. So you only had to go like one degree. You're still going to be, no matter what, O is going to work. Let's try letter P. See if you can get rotational symmetry at any point. No, 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 not P. P stays the same. And then let's try Q. Q anywhere along the route? No, because of that little leg. The leg with that extended out has to have 360 degrees before it gets to its original position. So that means letters N and O, spelling out no. Those are the only two that have rotational symmetry out of that list of letters. All right, nice job today, guys. Make sure you guys watch the entire video if you didn't already, and then make sure you do lesson 1 through 30, do your problems as you're working through the written practice 110. Have a great night, and we'll see you next time.